Hello everyone, this is Praveen. Now we discuss convolution of one's masked matrix and Gaussian filter. Here we can see the mathematical formulation of 2D convolution. Here X represents the input image matrix and H represents the mask R kernel and Y represents the output image. Basically, convolution can do something on the images that include blurring, sharpening, edge detection, and noise reduction, etc. What is mask? Mask is also signal. It can be represented by a two-dimensional matrix. The mask is usually of the order 1 by 1, 3 by 3, 5 by 5, 7 by 7. A mask should always be odd number because otherwise you can't find the mint of the mask. How to perform convolution? In order to perform convolution on an image, following steps should be taken. Flip the mask horizontally and vertically only once. It means we have to rotate the kernel by 180 degrees. Slide the mask onto the image, multiply the corresponding elements and then add them. Repeat this procedure until all values of the image has been calculated. Here we can see example of convolution. Firstly, we have to do zero padding to the input image. The process of adding zeros is known as zero padding and is required to be done in each case where there are no image pixels to overlap the kernel pixels. Zero padding requires to be carried on for each and every pixel which lies along the first two rows and columns as well as along the last two rows and columns. Addition of zeros to the image do not alter the image in any sense except its size. Here we can see once masked matrix convolving on input image. We have to place the center of the mask at each element of the image and multiply the corresponding elements and add them and places the result onto the element of the image on which you place the center of the mask. Repeat this procedure for each pixel and find out the output pixel. What is Gaussian filtering? In Gaussian filter, the weights are samples of 2D Gaussian function. Gaussian filtering is used to blur the images and remove noise. Gaussian filters are ideal to start experimenting with filtering because their design can be controlled by manipulating one variable, the variance. Here we can see 2D Gaussian filter function g of x comma y equal to 1 by 2 pi sigma square into e raised to power of minus x square plus y square by 2 sigma square. Here, sigma is the standard deviation of distribution. This function is used for creating a mask. The Gaussian filter works by using the 2D distribution as a point of spread function. This is achieved by convolving the 2D Gaussian distribution function with the image. We need to produce a discrete approximation to the Gaussian function. This is theoretically requires an infinitely large convolution kernel as the Gaussian is non-zero everywhere. Fortunately, the distribution has approached very close to zero at about 3 standard deviations from the mean. 99% of the distribution falls within 3 standard deviations. This means we can normally limit the kernel size to contain only values 3 standard deviations of the mean. An integer valued 5 by 5 convolution kernel approximating a Gaussian with a sigma of 1 shown below. The Gaussian filter is non-uniform low-pass filter. Its kernel coefficients diminish with increasing distance from the kernel center. Central pixels have higher weighting than those on the periphery, and larger values of a standard deviation produces a wider figure. It refers to greater blurring. Kernel size must increase with increasing sigma to maintain the Gaussian nature of the filter. Gaussian kernel coefficients depend on the value of sigma. At the edge of the mask, coefficient must be close to zero. The kernel is rotationally symmetric with no directional bias. Gaussian bias is separable, which allows the fast computation, and also Gaussian filter might not preserve image brightness. Here we apply the Gaussian filter to the input image by the given below 3 by 3 Gaussian matrix, and we can get the output pixel value for each pixel. Gaussian filter is more effective at smoothing images. It has its basis in the human visualization perception system. It has been found that neurons create a similar filter when processing visual images. The afternoon image at left has been smoothed with the Gaussian filter and is displayed to the right. Thank you.